Welcome, everyone. My name is Dan Schrag. I am a professor here in Earth and Planetary Sciences, across the street in the School of Engineering and Applied Sciences, and also at the Harvard Kennedy School. And I put this panel together called What Could Go Wrong? Now, the purpose of this panel, I want to explain just a little bit. It's not to wallow in terrifying things and scare everybody to death. That's not the purpose, although that may be a side effect. I'm a climate scientist who's worked on climate change for a very long time. And the way I see the climate problem is that we're doing an experiment on the planet that hasn't been done for a very long time. My core area was in paleoclimate. And so I studied Earth's climate over hundreds, thousands, millions, even billions of years. And so what we're doing is extraordinary. The higher carbon dioxide levels and other greenhouse gases is pushing the Earth into a place that hasn't been for millions of years and at a rate that's never happened before, the rate of change. And so I think what a lot of people fail to understand about climate change is that there's a lot we don't understand. And that's partly because this has never happened before. It's truly extraordinary what is going on, the experiment we're doing on the planet. And surprises are inevitable. And unfortunately, some people think that, and have in the past used our lack of understanding as an excuse for, well, maybe it's not going to be so bad. Unfortunately, in my experience, almost everything we don't understand tends to cut in the wrong direction. And the reason for that is that scientists are actually pretty conservative. Unless we have really good evidence that something is going to change, we tend to assume that it won't. We believe in 95% confidence intervals. So the fact that something might be 70% likely, no, that's considered not significant. So there's a lot of reasons for why scientists tend to be conservative about their forecasts, but every scientist who works in this area knows about things that are highly uncertain, but could very seriously happen in the future. And not enough attention goes into that. If you look at the IPCC, the assessments of the state of climate science, they're only allowed to deal with things that are published in the literature, and that excludes all these things that are highly uncertain because you don't write papers about things when you can't be 95% confident. And so there's a whole set of things that we worry about in terms of maybe a risk analysis, but that would never make it into the mainstream science. And what I am so delighted to share with you today is 4 extraordinary voices on this, each of them in somewhat different field. Kagan McCall is my colleague in Earth and Planetary Sciences and in Engineering and Applied Sciences. Kagan's a hydrologist who also thinks about meteorology, and he's been thinking a lot about the effect on human health of higher temperatures and higher humidity. And that's pretty scary for many regions of the world, particularly South Asia, Middle East, but maybe even the tropics as well. Missy Holbrook, next to Kagan, is my colleague in organismic and evolutionary biology. Missy is a plant physiologist. She's also the director of the Harvard Forest. And she and I have taught courses about nature-based climate solutions. And anybody who studies ecology understands the potential vulnerability of large-scale ecosystems to what's happening in the world. Caroline Buckey is a colleague in the School of Public Health. Caroline is an infectious disease expert and ecologist who thinks about all sorts of diseases, but has also done incredible work on mortality. Some of you may know of the incredible work she did in Puerto Rico after Hurricane Maria, documenting that the mortality after Maria was something like 80 times higher than what the government estimated. And that was really Caroline's work. And then finally, my friend Gabe Vecchi from Princeton. Gabe is a professor at Princeton and the director of the High Meadow Environmental Institute, what used to be the Princeton Environmental Institute. And Gabe is a climate scientist who is thinking a lot about extreme weather and storms, and is going to dig into his dark space about that. Now, again, some people say this is about pessimism. It's not. This is about realism, about science, about being a scientist and describing the world. And for me, the reason this panel is important is because we have to look at the real risks if we're going to plan for the future. we need to communicate this more clearly so that we can prepare for what's coming. And I don't think we've been doing that enough. So I want all of you to clear your minds a little bit and be ready to get dark, but also think about then, how do we respond to that? And I'm going to ask each of these scientists in turn to think a little bit about not what scares them emotionally, but what in their field they think that we might have missed and might be much worse than we think. Because it's important to explore that frontier in order to properly understand what our future might be and prepare for those risks ahead. So, Kagan, I want to start with you. Kagan, tell us about wet bulb temperatures.
Thanks, Dan. Yeah, I'm a hydrologist, and I'm interested.
You want to turn that mic up, maybe?
I don't think it's on. How do you turn it on? This button. Thanks. So yeah, I'm a hydrologist. I'm not a medical professional. I'm not an epidemiologist. And so the first disclaimer I always like to make when talking about this is there are many excellent folks here who already study heat stress in the current climate and are the go-to people to understand that. But as we shift into more extreme regimes as the climate warms, it can be difficult to extrapolate what we know about heat stress in the current climate to those more extreme regimes, and an understanding of the basic physics of the human energy balance can start to be useful. And so that's where I think folks with those sorts of backgrounds can start to provide useful perspectives. So many of you have probably heard of wet bulb temperatures and the sort of wet bulb temperature threshold. About 15 years ago, this sort of seminal paper was published that was asking a very basic question, which was, what are the most extreme conditions that a person could survive if they were sort of, in a theoretical sense, doing everything they could to mitigate heat stress? So they were not wearing clothes, they were lying indoors in an environment with a fan on them, they were sweating profusely, they were in very good health and able to maximally sweat. And the surprising result of that work was that, perhaps worryingly, the upper bound on what a human could survive was a lot lower than I think what many of us might have guessed a priori. And so that upper limit was a wet bulb temperature of 35 degrees Celsius. So a wet bulb temperature is a combination of heat and humidity. And you can sort of think of it as a combination of a temperature of 35 degrees Celsius under conditions where relative humidity is 100%. So these conditions don't arise naturally in the current climate, basically ever. There are some debates about whether it has ever occurred anywhere at all in the past, but everyone can agree that it essentially never happens in the current climate. But these are conditions that could conceivably happen as we continue to warm the planet. And so the consequences of crossing thresholds like that are that anyone who was exposed to that could not withstand those conditions for a significant amount of time. We're talking hours here. And so that has some obviously worrying implications. Since then, there's been a lot of work on sort of digging into this a bit more. We've done some work recently where we're sort of looking at areas of the world likely to be susceptible to this, and there's been a lot of emphasis on areas such as South Asia and India that are going to be experiencing these conditions. We also think that large parts of the tropics are likely susceptible to these sorts of conditions as well under sort of quite plausible warming scenarios. So these are some of the things that sort of keep me up at night when I sort of think about heat stress. So I'll stop there for now.
Thanks, Kagan. So I want to just probe that a little bit more. So, today, if you look around the world, there's literally just a handful of places that have ever experienced wet bulb temperatures above 35 degrees C, most of them in Saudi Arabia, and only then for like an hour or two, so we're pretty far from that. But during a heat wave, and a couple of weeks ago in Delhi, it was 126 degrees Fahrenheit, which the previous record I think was 118 degrees Fahrenheit. Luckily, and we really don't know how humidity is going to change. You think that the first place where we're going to see temperatures systematically above that wet bulb limit are going to be in the Middle East and South Asia, in the subtropics?
No, I think it's more likely to be in the tropics. So these areas are consistently hot and wet most of the way through the year, but that's speculation. I don't know. I guess on the second, just to be clear here, that 35 degrees Celsius wet bulb temperature threshold is an upper bound. So people die all the time in conditions that are way below that upper bound. Like today, probably this summer, there'll be people in Boston. And so that's really important to note. And just because we haven't crossed it even in the current climate doesn't mean, of course, people currently die all the time.
But there is something about this absolute limit, this upper bound, the idea that even if you're inside drinking water, healthy, it doesn't matter.
Exactly. And so the one caveat to that is that assumes no air conditioning. Of course, most people don't have air conditioning. And that's a really important caveat. But that's exactly right. This is not thermodynamically something that humans can withstand for a long period of time. It doesn't matter biologically what you are doing.
And again, huge uncertainty about what wet bulb temperatures will be in the future because we don't have perfect prediction of the climate, but we also don't know what greenhouse gas forcing is going to be in the future. But given all of that uncertainty, you want to give us a sense of the timescale that we're talking about?
Yes. I think it is a risk that we should take seriously in this century. And so I think there'd probably be debate on that, but I think it's absolutely something we should be taking seriously as possibly happening this century as part of any sort of risk analysis while noting this large uncertainties that you've mentioned.
And let's be really clear, there's a big difference between, say, India and equatorial countries. In India, you're talking about a heat wave that would go above the wet bulb temperature. In the tropics, it's high humidity. You're talking about just year-round temperature.
Yeah, so I think just because this is about a what could go wrong session, sort of you could imagine scenarios, and I'm not saying this is going to happen, but it is a plausible scenario that we should take seriously, that parts of the tropics become uninhabitable by the century's end. It may not be a likely one, but it is a plausible one, and I think we should take it seriously.
Great. Thanks. That's something
Just
to
ask
think
a
about.
clarification.
I want to hold questions, but okay, very quick.
Just to understand this concept, so the unusual thing there is the humidity, right? I mean, 35 is not that big a deal, but 35 plus 100%, what is the actual temperature that you feel?
Yeah, so just to explain the physics of this, one of the best ways that we have to cool is by evaporating sweat. Evaporation is driven in part by gradients in humidity from the skin surface to the surrounding environment. So when you have a wet atmosphere, you reduce that gradient and you make it more difficult for us to evaporate sweat. So the bottom line is it feels worse when it's hot and humid compared to when it's dry and humid. And that's what the wet bulb temperature is capturing, that information on humidity and temperature simultaneously. So yes, we regularly exceed 35 degrees Celsius dry bulb temperatures all the time. But the wet bulb temperature corresponds to 35 Celsius and relative humidity of 100% is one example of something that's consistent.
So in Delhi, 2 weeks ago, it was almost 53 degrees Celsius. Okay, 53 degrees Celsius, but luckily it was relatively low humidity. And that kept, we don't know what the mortality is. Caroline and I are working on that, but that kept it from being totally catastrophic. Next, I want to actually turn to Caroline. Caroline is an infectious disease expert who thinks about climate change, but from the perspective of a biologist who thinks about disease transmission. But she has a great imagination, and she knows a lot about mortality. So, and her two boys are in the room, so we have to be a little careful here, but I think it's okay.
Hi, everyone. So I'm an infectious disease epidemiologist, and most of the work I do is in the global south. I'm a vector biology disease ecologist, really. And so I want to talk about how we've changed as a species with respect to infectious disease risks and the existential threat posed by pandemics, especially when coupled with the potential for unlivable parts of the world in the future. So if you've all seen the sort of number of people on Earth, that curve that sort of looks flat and then shoots up, right? So we now are living in a highly populated, very dense world. And not only that, about 10 years ago, we crossed the halfway line to over half of us living in cities. So very dense populated areas. And, we often model infectious disease as if it's a forest fire. And from a forest fire perspective, we're basically making bonfires everywhere, piling up kindle, ready to go, right? So just from the perspective of how we expect diseases to spread in these populations, we expect that they'll go very fast relative to previous years. And in fact, Dan and I have once had a small argument about the Black Death, which happened in the 14th century. And the argument I was trying to make there was that we are no longer in medieval times, right? We now live in these very dense cities. We have large, densely populated, very poor areas surrounding the cities. And that's a problem just from a basic infectious disease spread perspective. So epidemics emerge all the time, right? They're normally from zoonotic reservoirs, and we know that as we cut down forests and as we mine for gold or we mine for resources, we are, on cutting down forests, which I think you'll talk about, we are exposing ourselves to more opportunities for zoonoses to emerge in population. One of the big problems is that our health systems are extremely fragile and they operate within political systems. The Ministry of Health is like one of the lowest ministries in terms of anybody caring about it. And because most middle-class people live in cities, the rural poor are often basically under-resourced. Our surveillance is very bad in those places. And so the opportunities for emergence are not only there, we then have migration between rural and urban areas that can lead to sparks for these forest fire-like outbreaks. So I guess my biggest problem, or the thing that I think is really going to be problematic, is that the health systems that we've built are extremely fragile, and they are particularly bad for poor and migratory populations. And so when parts of the world become unlivable, let's say Bangladesh goes underwater, let's say there are places where people can't live, there's no longer an opportunity to grow crops, people have to move. I should say we're already seeing mass migration to some extent. We are very bad at providing healthcare for people, conducting surveillance for people, and making sure that they don't die. And because we've got the sort of rise of populist governments and that we tend to try and push people out and keep them out with our borders, what ends up happening is that we have this myopic sense that we can stop a pandemic by just protecting our national interests. That's demonstrably untrue, as we've seen with COVID-19. One of the things that really worries me about this, the convergence of climate risks, emergence events, and the way that we live our lives, the connectivity between places, and this propensity for mass migration events that will worsen over time. One of the things that really worries me about that is that I don't think we've learned anything from the COVID-19 pandemic. We were very lucky with that virus. We were, of course, very unlucky in some ways, but it killed old people and people with comorbidities. That sounds crude, but if it had killed children and young people and had higher mortality rates, we would have been in even more trouble. As it was, we did a terrible job controlling it, especially in large countries with decentralized health systems. We saw a breakdown of international relations, totally inequitable distribution of things like vaccines. Since then, a lot of the funding has dried up because we've gone back to business as usual. That happened with Ebola, that happened with Zika, it's going to happen with COVID. Public health systems are reactionary. We're not good at prevention. So I don't have much faith that we've learned much. And geopolitically, I think we're moving into territories where people are going to become more and more nationalistic about protecting the health of their citizens at the expense of the global risk of a really serious pandemic in the future, which will happen. It's a low probability event, but it's going to happen at some point. So, yes, I think this is the first time my kids have seen me talk about this, and it's a little bit of a downer. I'm sorry.
This is the time. Let it out. This is the time.
So that's kind of my 2 cents.
Awesome. So much to look forward to, and very hard to predict.
Yeah.
Gabe.
Oh, I'm on. All right.
Gabe. Okay. You heard now wet bulb temperature and infectious disease. but you're thinking about something else.
Well, I should start by saying that I'm thinking about those things even before, but especially now. So one of the things that concerns me with regards to storms is largely, so that the table is set not by the things. Oh, I forgot to turn it on. Sorry. Can you hear me better? Okay. The table is set, Dan brought up sort of uncertainty and how we deal with that, but my table is set by things that I'm very confident about. So one of the things that I am almost certain about is that sea levels are going to rise and continue to rise, and that in many places that are affected by tropical cyclones, they're actually going to rise much more rapidly than the global average. So the Gulf Coast of the U.S. and the East Coast of the U.S. have been and will continue to be hotspots of sea level rise for very interesting but straightforward reasons. I'm not going to go into them right now, but they have to do with the rebound from the last ice age and a number of other factors. That I am confident about. I am also confident that the peak rainfall in storms is going to go up. It has already gone up, and it's going to continue to go up. Flooding, both from saltwater and freshwater, receive a lot less attention with tropical cyclones in the United States and other places with deep insurance penetration, but especially the United States, because it's not privately insured. But the main cause of death in storms is water. Wind is not the main cause of death in storms. And so sea level rise and a moistening atmosphere, which are, high school physics is all you need to understand, are one of the reasons I am really spooked about what storms can do for us. However, on top of that is the fact that many places we have been over the last few centuries, but really in an accelerating pace over the last few decades, building up cities, relatively vulnerable collections of human beings in places where tropical cyclones tend to make landfall. So in the North Atlantic, there was post-World War II, there was a buildup of sulfate aerosols. This is soot in the air, and that tended to cool the North Atlantic from World War II till the 1980s. And we've cleaned up the air, and there's been a slight rebound. And that, it seems like a digression, but it is not. Consequence of that is that temporarily we reduced hurricane activity in the Atlantic in the 1960s through the 1990s. That coincided with large-scale availability of air conditioning. In that period, for that period entirely, only not now, hurricane activity was less in the Gulf Coast and the East Coast of the U.S. We also have air conditioning, perfect time for everybody to move to these beautiful places, right? We've cleaned up the air. Global warming has continued. Sea level rise continues. You get more warm air with more moisture. We have placed not just wealth, but yes, wealth, but also people in harm's way without really getting a signal that global warming was increasing hurricane activity. Over the next few decades, I think it is quite likely, again, I'm not bringing up unlikely scenarios here yet. It is quite likely that we will see storms of an intensity that we have not experienced before, even as we've placed wealth and people in the way. When I start thinking about that, this is the United States now, where we have good financial system, insurance, reinsurance, ways to offset risk. I'm here thinking back to 2005 when we had two major hurricanes make landfall in the U.S. And what I heard, and this was rumors, was that a third one would start pushing insurers and reinsurers out of business. Who's going to insure us and reinsure us when we have three or four in the way? Right? So that is not a 1% situation we're talking about here. This is a 25% type thing, maybe even more. And you start thinking also about rapidly intensifying storms that the concept of rapid intensification in storms was something we didn't really talk about There's one or two experts that thought about it. Now it's in the newspapers, there's a Wikipedia page on it, it's in textbooks. And the reason is rapid intensification, that is a hurricane jumping 2 or 3 or intensity classes overnight, is a much more common occurrence, and we think that that is due to warming. We expect it to continue in the future. That makes those storms very hard to predict. So a lot of our plans of how to deal with storms depend on having forecasts and evacuation plans to deal with them. Well, if we don't have storm forecasting capabilities, then we're going to be in a much more dangerous situation. So I think even in the United States, hurricanes, with all the infrastructure we have, are one of the things that should keep us up at night. Now, when we start thinking about heat, hurricanes take out the power sector. You talked about using air conditioning to keep us cool when it gets hot. What if there's no electricity? We saw a preview of that in Houston earlier in the year, right? And what about disease? Right. One of the things that happens when you have a cyclone is a lot of our infrastructure goes down, including our public health infrastructure. You can have near-term and longer-term impacts on our health system, which could lead to disease outbreaks in the short term. But also, when you don't vaccinate people are walking around like taking time bombs, getting ready to get infected. So you could imagine all sorts of downstream effects from these storms. So storms are scary enough, but you start thinking about the interactions between storms and these other vulnerabilities, including these social vulnerabilities that we've created for ourselves. Not in a malicious way, we just want to live well. That is what is kind of scary.
So we saw some of that with Hurricane Maria. Caroline was on the ground in Puerto Rico after that storm, and the interaction with infrastructure, electricity, health systems.
Most people died not of water or wind.
Right. That's the difference between the 58 people the government said died and the 4,600 people that you calculated was that difference. But Gabe, okay, so you've talked with us about what's happening, and by the way, we're heading into a La Nina hurricane year, which this could be a doozy of a tropical cyclone year for these.
Yeah, I've never seen the large-scale conditions seem as conducive to cyclone activity as we're seeing this time of the year going in. The sea surface temperature in the North Atlantic is 2 degrees Celsius warmer than average, at least. In the Atlantic, the East Pacific is cooling off. Those are sort of the two ingredients that on seasonal time scales give us predictability. We could be wrong. But then that would even be scarier because we don't know how to predict hurricanes.
So, what you didn't do, and I'm going to just push you for 1 sec, you didn't think a little further out in time. So if we go out past 2050,
yeah,
obviously hard to predict the future, right? As it's attributed to Niels Bohr, but it's supposedly just a Danish proverb. Prediction is difficult, especially the future.
Right.
But when you do think about things a little further off, the physics get interesting, right?
So the physics get very interesting. You start worrying about the West Antarctic ice sheet. So what is that going to do to sea level? If the ice sheets in Antarctica are less stable than we think at the moment, or actually they're on the unstable end of the reasonable uncertainty bound, then you're going to have massive sea level rise in the antipode, that is the North Atlantic. And so that could make the situation much worse. We could live in a world that has a higher climate sensitivity, that is more warming for CO2 doubling than the central estimate. And so we could end up with wetter storms, more rapid intensification. It is, the potential for storms. We already have storms that have occurred that are arguably Category 6. There's no such thing as a Category 6 storm because the intensity spectrum caps off at Category 5 with no upper bound. But we've had Patricia in the East Pacific was a Cat 6 one. Haiyan, arguably a Cat 6. The impacts of storms are nonlinear with winds, meaning that you double the intensity, you get much more than double the damage. I recommend for anyone that wants to really get a good sense, there's a book, I forget the author right now, I have a porous brain, but it's called the Irma Diaries. It was written from first-person accounts in the British Virgin Islands there's a community there that has experienced many hurricanes, Category 4s all the time. Irma hit them as a Category 5. And these are people that are pros. They've lived through many, many hurricanes, and their descriptions were of a categorical difference in what they experienced. This is now a Category 5. Imagine a Category 6 or 7. And so if we want to look beyond, and it's not, again, I'm not pushing into the 1% of the future. There are scenarios out there that should be taken seriously. Where we have Category 6s and 7s as part of what we have to live with.
Thanks, Gabe. Yeah. Missy Holbrook. So,
it's on now.
Good. So, Missy, you think about different things altogether.
Well, as you'll see, maybe not all that different. So I think I'm the Lorax on the panel. I'm going to speak for the trees, and I'm going to tell you sort of what is a plant worried about. And really, so water has everything to do with how plants take CO2 out of the atmosphere and grow and survive. And plants don't like it when there's too much water. You just talked about intense, when the ground is flooded, their roots are basically gasping for breath. And there's weird microbial gases that are problematic. And they really don't like it when it's dry. And usually when it's dry, it's hot. This is some of Kagan's work. Because then they can really have lasting damage. Their leaves can heat up. Normally they're able to cool. But when they heat up, their water column, they're pulling the water up out of the soil. It breaks and they cannot reconnect that. So they have this lasting damage. And so plants can be damaged by these weather extremes. Now, will they be killed by it? No, plants are tough. Plants are kind of compartmentalized. They'll keep growing. But what will happen is pests and pathogens will come in and get them. And we will get what you might think of as a regime shift in the ecosystem. So we're seeing this already here in New England. Climate change is affecting plants here to some degrees. Some are growing faster, some are growing slower. But there's a large number of invasive insect pathogens that have come in from other continents, and also some diseases, and they're wiping out different species locally. They're not going extinct, but for example, the hemlock, which is a big late successional tree, is basically disappearing and being replaced by black birch. Black birch stores much less carbon and has much less biodiversity living in it. And so what I worry about is plants' physiology being weakened by the episodic water, both too much and especially too little, so that diseases come in and get them out. And then we start to see our ecosystems transformed, usually in directions of higher disturbance, more susceptible to fire, less carbon storage, and altered biodiversity, usually in ways that we don't like. So that's kind of my fear.
Anybody who spent time in Colorado knows about the pine beetles and the massive hillsides of dead trees from that. But 20 years ago, colleagues in ecology were talking about potential, again, very uncertain, but potential massive ecosystem change in places like the Amazon, where you could actually convert a forest to a grassland. Is that still?
So you can envision, you can sort of model that on a climatic scheme, but I think it's more likely to go because of climate weakening plants, disturbance coming in because of disease, and then larger disturbances like fire. So I can see that playing out, but in a not solely just, it'll be many interacting effects. And I feel, let me just say a little bit about agriculture, because that's the other area that I think is important. And one of the ways to mitigate against climate change is to irrigate. And what I worry about, of course, is soil salinization, that, if we are not careful with our irrigation, we will end up accumulating salts in the soil and degrading our good agricultural lands. So any water that is run through the soil is naturally picking up salts, and as you keep putting it back and back onto the land, it does accumulate. And so that's one of I worry about that for places that can irrigate, and for places that can't irrigate, I just worry that the productivity will be too low and people will abandon their farms, which is what happens in the US when we have a bad weather that people just plow under, they don't bother to harvest. And in other countries, they just migrate because they cannot, their livelihoods are gone. So I do worry about temperature drought effects in agricultural systems from multiple perspectives.
So I want to turn to the audience in a minute, but first I want to actually go backwards and ask each of you to react to what you heard from the others. Missy, you've been thinking about all of these things for a long time, and you've been listening to your colleagues talk about this.
So I was really, when Kagan was talking about that scenario of really wet and really hot, and I was trying to imagine plants in that scenario, because usually when it's, plants are really good at evaporative cooling, and so I don't think of them as like, in that scenario, they could overheat as well, just like humans. We're trying to figure out what is that temperature threshold. Threshold is really the wrong word. What is the sort of trajectory of temperature damage? And so I would like to follow up with Kagan and think more about
Really interesting
that.
issue, actually.
Yeah.
If you're a dark leaf in on an equatorial sun and you can't evaporate because it's 100% humidity, that's a little scary, right?
It's really scary for a plant, but it is. I don't think plants have ever experienced that, but you could imagine them suffering from that. Yeah.
Caroline. Oh, well, we can go. Just whatever.
Well, so this issue of biodiversity collapse is something that I think is very interesting.
I've got to be clear. Caroline's degree is in zoology, and so she secretly cares about those animals.
And I think the plant pathogens and the human pathogens, right? These are combined, pretty existential, and so that's just added to my list of things to worry about at night. I wanted to comment on the mortality issue. So when we talked about what people die of in storms, generally speaking, for all of these things, including for heat, the long tail of death is going to be far more significant in.
You turned it off.
No, it's on. Can you hear me? Yeah. The long tail, which we're not good at measuring because it generally comes out in death registries in ways like cardiac event, dialysis, failure, this kind of thing. The long tail of how many people are dying from extreme weather events, from excess heat, we don't know those numbers. We don't understand the physiology, and we're not capturing it in our health records because we fundamentally don't know some of these things very well. So when you're talking about the extreme storms and the fragility of the infrastructure that's required to keep people alive, right now in high-income countries, a large fraction of people are reliant on electricity-dependent medical devices, refrigeration from medicine. They have to go into a clinic to get their dialysis or whatever. They rely on emergency response. When you disrupt infrastructure through storms, you break all of those very fragile threads. And already populations in the global south have very fragile infrastructure. And so my concern is that it's not just this gradual creep, it's the combination of unpredictable, intense events that destroy and smash stuff up, coupled with this creeping problem and the fact that we don't fully understand the physiological impacts and really what to expect in terms of the physiology, the health needs, and the mortality, that I think came through to me in the comments, both about the unlivability, the idea that our crops are going to die of pathogens and cause mass migration, and then this idea that we have extreme events that take out whatever infrastructure we can build up in between. That seems like a convergence of bad things.
Dave?
Yeah, what my reaction to all this is that each one of them is pretty sobering to think about independently, but they're all so obviously easy to interconnect that we'd have to imagine a very fortunate world which I don't think we necessarily live in, for them not to constructively interfere, right? For sort of most of the studies looking at storms, look at storms, assuming everything else stays constant. You look at disease, assume many of the other things stay constant. Look at changes in agriculture, assuming all the things stay constant. Thinking about extreme heat, assuming the other things stay constant, because that's how we think, right? We make one perturbation to the system and then and think linearly. These things, plus others that we haven't talked about, are likely to sort of interact in a way that the net effect of all of them happening is going to be harder to deal with than the sum of the effects of each one. And so, I'd love to go back to a linear world.
Yeah, so much interesting to think about. I'll just make 2 points. So Gabe mentioned this impact of storms potentially knocking out grids, knocking offline air conditioning, and the impacts on heat stress. And you mentioned the situation in Houston where that happened recently. And thankfully that was not an exceptionally hot day when that occurred. I think it's something like 80% or thereabouts of Houston has access to air conditioning. It's obviously expensive and you don't use it unless you absolutely need it. If you look at a city like Phoenix, it's 99%. And there is published literature this year that ran a scenario in which that was knocked out for a period of 24 hours, and they estimated the mortality burden from that event. And what they estimated, and this is in peer-reviewed literature, it's not stuff I've done, but it's been published, is that 50% of the Phoenix area would be hospitalized in that scenario. Now, we can quibble about that. I don't know if that's right or not. Maybe it's 10%, but whatever you think of that, that's a really horrifying scenario. And just building, and second point, just building off what Carolyn was saying, it's about this notion that it's sort of hard to kind of measure this sort of mortality burden and how much of a problem that sort of is. Just even asking the question, how many people are dying of heat stress at the moment is so complicated and difficult. And that's in the United States. If you go to sub-Saharan Africa or parts of the Amazon, it's really tough. And so that's a major kind of obstacle to kind of better understanding this stuff.
Caroline and Sajid Balsari and I and a couple of other people are working on trying to figure out what that mortality is during heat waves in South Asia. And it's really hard. I don't know, I hope we'll succeed, but it's really hard to do. Thank you may not be quite the right word to use, but this is fabulous. By the way, Kagan, for those of you who don't know, Kagan, later this week, Kagan has organized an incredible workshop with about 30 scientists from all over the US, all over the world, who are going to come here to Harvard to talk about, it's not open to Climate Week participants. It's a scientific thing that to talk about continental climate, because this is a hot area and our understanding continues to change. This is a really dynamic area. Keegan's been leading that. I want to open it up to some reaction from the audience, but first, there are a couple of people in the audience that I wanted to ask what their reaction was, because they're sort of esteemed colleagues, but not necessarily, well, one of them's from academia. The first is Nat Cohen, who's sitting there and he's laughing. But Nat is the president of C2ES and is an economist, very thoughtful, and is thinking about all of these aspects of climate. And I'm just curious, Nat, what's your reaction to listening to this now?
Thanks a lot, and thanks to the panel. I mean, I guess my first reaction is I think a lot about potential tipping points and what could go wrong, and these weren't on my list, which already had a dozen things. So that's not reassuring. I think I guess the ones that I have thought about, or people that I've talked to have thought about, I know others in the room have thought about, are things like the positive feedback effects, where if methane, for example, starts with, I missed the earlier session on the Arctic, but I'm sure we had plenty of doom and gloom about that. But some of the positive feedback effects associated with methane being released from the tundra or cloud freeze. The other point I would raise, I mean, obviously, Missy, you know huge amounts more about this, but my sense from having used to work in the Amazon, like with colleagues in the Amazon, no longer do, but at the Environmental Defense Fund I did, my sense was that the Amazon scientists really are worried about approaching the tipping point in the Amazon in particular because of the climatological changes that are associated with global warming. So Dan, you had raised that one, and my sense is we are coming a lot closer to that. I know, Missy, you were talking about the broader set of, I may have misheard you, but you were talking about the broader set of issues, but losing the Amazon forest to a savanna seems to be
Kind of a big deal.
kind of a big deal.
So I agree. We're close climatologically, but it's going to accelerate because of diseases. Is going to make it go much faster than the model of what just the climate effect is. I think that's what I really worry about.
Understood. Thank you.
And the other person I wanted to just get his reaction to is actually Nat's father, Bob Cohen. Bob is a political scientist. He was chair of the Department of Government here at Harvard for many years. He moved to Duke and then to Princeton, and he now lives here. Bob, you've been doing this for a long time. What do you think of this?
So I want to ask you about the policy responses. What would you suggest to a policymaker in your area of expertise to do about the problems you mentioned?
Caroline, you want to start?
Sure, this is easy, so that's fine. No, I think global health has to be turned a bit on its head. I think we have this archaic system where we have money and decisions being made in the global north in places like Geneva, handed down, we saw this during COVID, handed down to global south countries, policies for public health. And that is no longer a viable model. There has to be a fundamental shift in agency and decision-making, global decision-making around that, around what we're going to do. And there has to be regional coordination on some of these disease threats. Surveillance is a very big problem because it's not in, Indonesia's interest to say that they have X number of cases of an unknown febrile illness, right? This is a global problem, but it has local political repercussions. And so I think there has to be both regional and global South-South partnerships that are built up with, really, I think they should just move the WHO to the global South right away. And so the other thing that I think is that we have to take seriously the notion that communities should be equipped to measure and deal with outbreaks themselves. What we saw during COVID-19, for example, is that communities that were empowered and organized did way better, because in the end, if you think about all the complex modeling that happened, what were the interventions? Wash your hands. Don't go into crowded places, right? These are relatively basic things that could be done on the community level. And we need to scale and roll out a much more comprehensive approach at community level.
Any other reactions in terms of policies? What don't stop shaking his head.
We need to invest more in agricultural research, and we need to really protect our agricultural soils from poor irrigation practice, which I think is going to become more prevalent as temperatures go up. So, we don't, as a society, invest very much in agriculture. So that would be a policy decision that I would advocate for.
So I think from the point of view of storms, at least in the short to medium term, enhance investment in improving our forecasts. I'm talking about a 3, 5, 7-day forecast. But then thinking longer term, really taking the need to adapt to a changing climate seriously. And this will include, if one is serious about it, thinking about retreat. And how do you manage retreat equitably, and in a country where we've sold people the idea that your home that you live in, keep your stuff, is somehow wealth. It's not. It's a place where you live, and in a changing climate, it's also risk, right? I really so from and that one there, you can imagine from a policy point of view, I don't know how you sell that.
Okay, we have about 10 minutes left, and I really want to get as many questions as possible on the table. So I'm going to pass the mic. We're going to get a series of 3, maybe even 4 short questions, and then we'll ask the panel to respond, and then we'll do another round of that.
I'm Nova. I'm from Manila. I live in the tropics, and my climate anxiety level is at this high. I don't think I can go to the mixer tonight. But anyways, it's a good thing that you'll be convening like a workshop for scientists to get to know more about the heat stress that you were explaining earlier. I'd like to know, apart from that, how is the knowledge being shared, and are there any collaborations with your counterparts in other academic institutions, especially in the tropics, about this issue?
Thank you so much. Okay. Yes.
Thank you very much. My name is Idogese Samson. I just graduated from the Harvard School of Public Health. I really appreciated Gabriel's last one of your comments around the fact that the issue isn't linear. And I think that helps us appreciate how much we need more like systems approach towards tackling the challenge. And so my question is it feasible to approach the climate crisis from a systems perspective? I personally appreciate the complexity of that from a political and just a practicality standpoint, but I'd be curious to hear your thoughts on that.
Thank you. And one more, maybe from this side of the room. There you go.
Thank you. Great discussion. My name is Derek Patterson. I'm from Vancouver, BC. Just a couple of areas that you referred to that we didn't touch on. The implications of global warming for the jet stream. I know they've been talking about more severe turbulence and all that, but are there other implications? And I'm also curious about the status of acidification of the oceans happening, and what is the status of that? How much threat is it to sea life now? Is it a current threat? Is it a couple of years away until we see broad impacts on the different species of ocean life?
Thanks. Okay. We heard 3 questions. Any quick reactions?
So the question about thinking about climate change sort of in a systems approach, we're going to have to. It's not should we or can we. You can't think about it piecemeal. And so fundamentally, we have to think in a complex systems way. And then in regards to the jet stream, there's a lot of uncertainty as to what the jet stream should do and the storms that it carries. But the general consensus is that we should expect a poleward shift of the jet stream. So places that count on the jet stream and the associated storms to bring them rainfall may see that on average moving away from them to the north. And there's a lot of, and so that's one of the concerns to have, thinking about a place like Vancouver, Victoria, Seattle. Polar shift of the jet stream may matter. And then with ocean acidification, it's acidifying. It's pretty straightforward chemistry. And, if we're not fishing the oceans too extensively and too much aquaculture, then perhaps it won't be that much of a stress in the near term. But if simultaneously we're extracting more of our food from the ocean, fishing more intensively, you would imagine that the 2 stressors will combine to be more than each individual one.
I'll say something very brief about ocean acidification, because sometimes it's held out as this really terrifying thing. People hear about it. And, oh my God, the oceans are acidified. Ocean acidification is particularly a problem for organisms in the ocean that grow their shells out of calcium carbonate, in particular coral reefs and corals. That being said, it's quite clear that warming is much more impactful on coral reefs than ocean acidification. And so, frankly, ocean acidification is lower on the list. The question you asked about ecosystems in general and marine life, Gabe's right. The first, second, and third problem with marine ecosystems is overfishing. Right? We're vacuuming the fish out of the ocean. And then, if we really cared about marine ecology, we'd stop overfishing. Ocean acidification, though, it's very complex. It's not clear. It's definitely going to affect ocean ecosystems, but it's not clear whether it's going to increase or decrease the overall types of species, because ultimately the nutrients are there. There will be algae that grow. There will be organisms that eat those algae. There will be fish that eat those organisms. So the food chain is going to exist. It's just what exactly is it going to to be, really hard to predict. Very difficult. Any other reactions to any questions? What about the global south or global tropics?
Yeah, thanks for the question. Yeah, I mean, I think this is so important because the global south, like much of the impact of climate change, is going to, I think, bear the brunt of this sort of heat stress burden. And so, a lot of the work that is done, the sort of seminal work I talked about, is assuming a scenario in which a person is staying indoors, sheltering, to figure out this sort of upper limit. But there's something like 1 billion people who have to walk outside to access clean drinking water every day. And so just even that simple kind of activity that a person can do to kind of reduce their heat load is not factored into those sorts of calculations for folks in that situation. And so I think there's just a ton of work to do to better understand that additional heat load that folks in some of those environments face because of socioeconomic factors. Yeah.
Any other reactions to any of the other questions? Okay, let's get a few more over here on the side.
Thank you. Good afternoon. My name is Adam Frost. I'm a student investor. Just wondered, Hagen, if you had any comments on the paper that came out in 2003 from Professor Rippert, I think it was, at the University of Oregon, suggesting that between 3 and 6 billion people could be affected by uninhabitable parts of the world. That's quite an extreme figure. Any comments on that?
Yeah, I'm not. Yeah, I'm not familiar with that work from 20 years ago. So the work that 2023. Yeah, okay. So migration. Who was the first author?
It was Oregon State University, Professor William Ripple.
No, not off the top of my head. Sorry. Yeah.
Other questions?
I have a question. I won't need a mic. Thanks for the panel.
Your mic because we're being recorded.
Okay. Thanks for the panel. Really appreciate it. How do you get out of bed in the morning? And it's not a joke question. I teach high school students, and how can we give them hope when we talk about climate change?
How do you get out of it? I mean, it's a lot of things to do. I get to teach, and I have friends, and those types of things. I love my kids and my wife, right? But seriously, just because we're highlighting the challenge, the last thing that we should do is look at the monumental nature of the challenge and then freeze up, right? The monumental nature of the challenge is mapping for us what we need to face up to, and it may sort of the realistic bounds of what the future will look like, even with the best possible outcome, may not be perfect. But I think that if we pretend the potential outcomes are better than they really are, we won't rise up to the challenge. We'll be unprepared. And knowing how challenging the situation is, we might get together, work, and actually come up with solutions that work in the long term.
I think about this a lot because a lot of my colleagues in the environmental movement say we have to give people hope. We have to tell them, we have to give them hope. We have to tell them news. And I feel like that's wrong. That giving people hope based on delusion is not hope. It's just delusion. We're scientists and we have to tell the truth. That being said, where does hope come from? I think the answer is it comes from us. That is, we can all make a huge difference in the world. And I think that's the important thing. That we're not talking about a world where people don't have happy lives and can have the joy of family and friends and community. But these are real challenges that the world's going to have to face. And the most important thing is by understanding them, to reiterate what Gabe said, and ultimately leads us to be better prepared for them. And if there's one thing that I think climate community is underestimated, it's how adaptable humans are. Remarkably adaptable and hard to predict exactly how they're going to do it. But there's a lot of, to me, hope in the human response. But that response will only happen if we describe what the issue is. If we tell people only the watered down version, that's not helping. Keith.
Well, there's a missing fifth panelist. 25% probabilities, let's say across the board. I don't see any existing government that would be standing in its current form. The acceleration of the end of democracy, anarchy, survival of the fittest. Do you think in those science fiction terms, which I'm getting rid of the word fiction now, because this is now science?
Any reaction? This is not what the panel was set up for. But yeah.
I mean, I think the mass migration events that I was talking about before are inevitably going to lead to political conflict. And, Sajid Balsari, our colleague, he works on human health in war and disasters. And I agree. I think that the sort of political aspect of this, the disintegration of government, the health systems that are already so fragile are gone. But just to the point of the hope, with my nearly high school age son in the back there, I really have faith in human adaptability and in communities. I think that there is a lot of stuff that we can do at the community level, and things might get bad and have to get bad for us to get there. But I do think that humans are ingenious, and that there are ways in which, regardless, at that level, not the government level, there is cause for hope.
So it's 4:30 and we have to end, unfortunately, because there's another event happening at 4:45. But I just wanted to say, this was a panel set up to ask the question, what could go wrong? And again, there are all sorts of things that this panel couldn't cover because that's a really vast question. But I hope you got a sense for both the uncertainty and the potential risks going forward. In an ideal world, we would follow this with another panel that said, what do we do about the things that could go wrong? That's maybe a topic for next year, but it's a really important question. It's a different set of people, and it's part of the reason why communication between those different communities is so important. And one of the things the Salata Institute tries to do is create those dialogues between the people who say, okay, Kagan says, oh my God, these wet bulbs could happen. Well, then how do you think about it as a political scientist, as an economist, as a sociologist, as somebody who studies history? So there's a lot of information from that interaction. I hope you'll take this away not to be disheartening, but actually to see what the challenge is that lies ahead. And that's what we have to do. Let's get going. All right. Thanks very much.